2,520?
Dude, that's awesome. Don't ever become a pal.
Yeah, buddy.
Don't ever.
Good.
Yeah, that was good.
Thank you.
All right, one more.
Sure.
We got 97 times 49.
4,753?
Sabornu Isaac, a god of math.
One. That's
Thank
sick,
you.
man. Good job.
Wow.
Yeah.
What the
Good job, man. Good job.
My name is Professor Sabornu Isaac Bari from the Da Vinci Institute, South Africa, and today on Math for Children, we're going to be doing lesson 4.2, subtraction in different bases. This is the base we all use in everyday life, where we have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably because we have 10 fingers on our hands. So, base 10 is what we use for everyday life, but other bases, like for example base 6, use a different amount of digits. Since base 10 uses 10 digits, base 6, for example, uses 6 digits, 0, 1, 2, 3, 4, 5. And the smallest is base 2, which simply uses 0 and 1. This is also known as binary. Okay, so what we're going to be looking at today is subtraction in different bases. So let's start with base 10, just so we can get used to that. And then we have base 9, base 8, base 7, base 6, base 5, base 4, base 3, and base 2. Okay, so base 10, just as a starter, we all know how to subtract in base 10. Let's do, for example, 78 minus, 19. Okay, so here, 8 minus 9, that's not possible. So what we're going to do, we're going to take 110 off this 7. So this 7 is going to become 6. This 8 is going to become 8 plus 10 is 18. So 18 minus 9 is obviously 9. 6 minus 1 is 5. 59. That's simple. Okay, base 9. Let's say we have 58 base 9 minus 43 base 9. Keep in mind, in base 9 you can't use the number 9, or the digit 9 rather. So let's actually change this problem up to make it a little more interesting. So let's say this is 54 and this is 48. Sure. So 4 minus 8 is impossible here, so we're going to have to regroup. So once we cross off this 5 and make it a 4, remember our places. So this is going to be the 1's place, but this isn't the 10's place. It's going to be the 9's place because we're counting in base 9. After we reach the digit 9 instead of the digit 10, we go into this place. So that means that this 5 represents 5 9s, or 45. So once we take 1 9 off that, we're going to add 9 to this 4. That's going to make it 13. 13 minus 8 is 5. Now, not literally 13 if you want it to be technical, but that's how we're going to write it for ease. So, and 4 minus 4 is just 0. So we have 5, base 9, as our answer. So, for base 8, we can also just simply do subtraction. Let's subtract that from, let's say, 21 base 8. And this is just simple. 22 base 8. So now, let's go to an example with regrouping again, just to get familiar with it. So for base 7, let's do 61 minus 16. So here, this is the 1's place and this is the 7's place. So what we're going to do is we're going to borrow a 7, and this is going to be 1 plus 7 is 8. 8 minus 6 is 2. 5 minus 1 is equal to 4. 42 base 7. Okay, so for base 6, I'm going to show you how you can basically bring things over. So, I know that sounds confusing. Let me show you. So, let's say we have 1,000 and, what can I do here? Let's say we have 104 basics. We were subtracting it from 45 base 6. So what can we do here? Well, this is the 1's place, the 6's place, the 36's place. So 4 can't go into 5, but obviously we can't borrow anything from the 0. It's empty pocketed. So this 1, which represents 136, we're going to cross it out and give that 36 into the 6's place. So basically we just add 6. So this is going to become 6. And then we can just borrow from here. 6 becomes 5, and this becomes 4 plus 6 is 10. 10 minus 5, 5. 5 minus 4, 1. 15 base 6. And that's really it when it comes to base subtraction. So we'll do 4 more examples just to cement your hold on this. So let's do 720, wait, no, not 7. Let's do 423 base 5 minus 134 base 5. So here we're going to borrow from the 2. This becomes 1. This becomes 3 plus 5 is 8. A tip, when you're borrowing, make sure to always add the number of the base to the number that's getting added from. I don't know how to say it. Like, for example, here you would add 5 to 3. If this was base 6, you would add 6 to 3, etc. And in base 10, as we saw, we could add 10 to these things. 8 minus 4 is 4. 1 minus 3 is, again, not going to work. So we're going to make this 3. We're not going to add 10, but rather 5. 6 minus 3 is 3. 3 minus 1 is 2. 234 base 5. Alright. So now, let's do base 4. 302. 3 base 4. And then, let's put 3, 2, 1, 2. 2, 3, 1, 2 base 4. Okay. 3 minus 2 is 1. Now, we can't, well, 2 minus 3 isn't going to work, but we can't borrow from the 0. So, we're going to take this 3, subtract from it. This is going to become 4. Now, we subtract 1 from it to make it 3, and add 4 here, making it 6. 6 minus 3 is 3. 3 minus 1 is 2, and 2 minus 2 is 0. 231 base 4. Alright, so for base 3, we're going to have, let's say, 201 minus 220. Well, actually, no, one number here is bigger than the other. So let's do that differently. 120. Okay. So 1 minus, and let's specify. 1 minus 0 is 1, obviously. Now 2 minus 1 is 1, but 0 minus 2, that's not going to work. So we're going to borrow from here. This is going to become 3. 3 minus 2 is 1. 1 minus 1 is 0, so it's just 11 base 3. Okay. And for base 2, let's do 1011 base 2 minus 1001 base 2. Well, no, that's not the most creative thing in history. 1101 minus 1011. Okay. So 1 minus 1 is obviously going to be 0. 0 minus 1 isn't going to work. So we're going to make this 0. This is going to be 2. 2 minus 1 is 1. 0 minus 0 is 0. 1 minus 1 is 0. So it's just 10 base 2. And that's really it. Thank you everybody for watching, and we'll see you in the next one. By the way, since it's Women's History Month, don't forget to celebrate what women have done for our scientific community.